Recording in progress.
Hi everyone that's here. We'll be getting started in just a minute. All right, so good evening everyone. We will get started. Don't forget that, well, I'll do the question at the end for all the latecomers. Hopefully people haven't had too much issue with homework. And today I believe, so let's also hope, I'm gonna save these notes before I move on, and let's really hope that I do not lose some writing like last time. But I did figure out how to just add the page and it should be all posted on Blackboard. So I'm 99% sure the notes on Blackboard are all up to date. If this is not the case, just email me or let me know, right? Okay. And I don't know how to like get rid of this video on my Zoom. Like, is there a way? Oh, to do that? Yeah. Okay. Oh shoot, it still shows up. All right, forget it.
The page is very narrow. There was a last.
This. Yes, there
Right,
we
there you
go. Okay, thank you, Michael. Okay, I totally forgot, but obviously, okay, we'll get used to this and I'll remember next time. Okay, cool. So for this, I'm just gonna kind of talk through some things. But here we can see we're talking about reciprocal and quotient identities, right? So these are those, we talked about sine, cosine, tangent, and then cosecant, secant, and cotangent, right? And so here we have cosecant is going to be 1 over sine, or you can reverse it. Then we'll have secant is 1 over cosine, cotangent is 1 over tangent. And then we do talk, or this here says tangent is sine over cosine and cotangent is cosine over sine. So this is just kind of a table for you. And in the previous page, if you remember, oh geez, if you remember, oh, I have to put, oh, all right, this is going to be annoying. Hold on, I have to remember how to do this. Don't draw with finger. There we go. I was trying to scroll. Okay, here we go. So in the previous page, we found that like this is equal to cotangent and this is equal to tangent. And so that is just listed right here. Like we found this on the previous page, right? Okay. So now let's do some problems here. So suppose theta is an angle such that cosine of theta is 2 over 3 and sine of theta is root 5 over 3. So we're going to just use the identities and answer this question, right? So tangent is sine theta over cosine theta, which is just going to be square root 5 over 3. And I'm literally pulling it right from these guys, right? So it's just going to be square root 5 over 3 over 2 over 3. And this is the same thing. I mean, you don't need to write this step right here, but when we divide by a fraction, we're multiplying by the reciprocal. So it's the same thing as doing this. So I know you could have just said, oh, the 3's cancel, or you could write it out here and see, oh, the 3's cancel. Okay. Oh, shoot. I'm also forgetting. I need to try to see Zoom on my computer. Okay. To see the chat. Sorry, let me pull the chat up just in case there's any chatter. Okay. Okay, cool. better. So now my final answer is just going to be square root of 5 over 2. And I don't have to rationalize that. I don't have to do anything. Now remember cosecant, I mean, it's up above, but also, it's right here. So also you should know that that's just 1 over sine of theta. And so that's going to be 1 over square root 5 over 3, which is the same thing as 3 over square root of 5. And then we will rationalize this, right? And we will get 3 square root of 5 over 5. Perfect.
Question.
Oh yeah, go ahead.
So in that table that says the title says reciprocal and quotient identities, and you can clearly see like the first 3 rows are it says reciprocals on the right side. Is that are the tangents the quotient? Is that what that means?
Yeah, so the tangent and the cotangent, they're the quotient of sine and cosine, or vice versa, right? Yes. And sorry, David asked, what's the chart for all the sine, cosine, tangent? You want to print this chart, the reciprocal and quotient, or SOHCAHTOA, or I'm not sure what you're asking about there. Maybe Michael asked the same question. And then Veronica says, are you getting the 5 on the bottom from square root of 25? Yeah. So on that bottom here, I multiplied, I got, square root of 5 times square root of 5 is square root of 25. And so that's just 5. Like sine is 5 square root and so on. So David, if someone knows what David's talking about, go ahead and type in the chat or something. Maybe I'll understand in a minute, but I'm not sure what you're thinking of, what chart. Like the 30, 45 or 30, 60, 90, like special right triangles. I'm not totally sure. But if it comes up or you can think of, okay, find it in the previous lecture. Yeah, thank you. Sorry about that. Okay. So part B here, it says draw a right triangle and verify your answers from part A. So we want to draw a right triangle. So I'm just, again, you could have the right angle here. You could also draw it, this way, but I'm just going to draw it this way. And we have our theta here. And
different for the
Jakob, yeah.
Yeah, for the cosecant theta, I got on my calculator 2 square root of 5 divided by 5.
2 square root. Did I write something wrong?
I don't know.
Well, you're doing this in your calculator though. They gave us, so are you using the information they gave us in the problem here that cosine and sine are these things?
Mm-hmm. Yeah.
Mm.
Maybe I did wrong. Sorry.
No, it's okay. Just check, double check what you entered. But yeah, I'm pretty sure this is good. But yeah. And so with our right triangle here, basically what we're just doing is we're saying, okay, tangent of theta is opposite over adjacent. Cosecant theta, like that's what we were solving just up here, right? Is hypotenuse over opposite. And I'm doing this quickly, but this was just from last class, right? And what we're doing with our right triangle is we can label it because we were given these here, except I just wrote over them. But so cosine being 2 over 3 means cosine is adjacent over hypotenuse. So adjacent is 2, hypotenuse was 3. Sine is opposite over hypotenuse. So square root of 5 is this, right? So from this, we can figure out, are these what they need to be? Like, did we do the correct thing for 1 and 2 above, right? And so we can see, okay, so opposite over adjacent should be square root of 5 over 2, which is what we got for tangent. And hypotenuse over opposite, hypotenuse is 3. Oh yeah, is 3 over square root of 5, which we then could get 3 root 5 over 5, right? So this should be correct. or this is correct based on that. Ooh, sorry, went way too far. What the heck just happened? Okay. Okay, so now we have here given cosine of 75. So cosine of 75 equals this thing. They're giving us this. And it's saying use the fundamental identities. So the identities they gave us to find secant of 75, right? So to do this, we just know that cosine of 75 degrees equals, well, okay, maybe I should write it as secant first, but we know that secant and cosine are reciprocals, is 1 over secant 75 degrees. And so what that means is secant is 1 over cosine, right? So what this tells us is that secant 75 is going to be 1 over this whole thing here, square root of 6 minus square root of 2 over 4. But again, we don't like to divide by, like when we're dividing by a fraction, it's multiplying by the reciprocal. So this just is the same thing as 4 over square root of 6 minus square root of 2. And then this is tricky to rationalize this denominator, but we can do it. It's just a little trickier. So we're just going to do a little, I'll show you what to rationalize this. If you haven't seen this, you multiply by the conjugate, which just means change the subtraction to a plus. So we're going to multiply the top and the bottom by this. And in the numerator, we don't change anything. We just, because the numerator can be messy, we just leave that the same. But then in the denominator, we are going to calculate this here, and we'll just kind of do it off to the side. So square root of 6 minus square root of 2 times square root of 6 plus square root of 2. And so remember, we do the first, so that just is square root of 36, which is just 6. We do this next one, 6 plus square root of 12. Then we do this inner one, that's minus square root of 12. Ooh, those will cancel. This is the whole point, very nice. And then minus square root of 4, which is just 2. So when we simplify that, these cancel, and we just get 6 minus 2, which is just 4. So we just get 4 in the bottom. This whole thing will equal 4. And now the nice thing about this is these 4s cancel because we're simplifying even more. And so then our final answer would be secant of, I'm rewriting the secant part, of 75 degrees is going to be square root of 6 plus square root of 2. And if you want to write yourself a note here of what we did, we rationalized by multiplying by the conjugate. That is what we did here. Oh, and thank you, Charles Miranda. So there is an answer about that to David. So maybe that will help. So now we're going to look at co-function identities. And this just means, so co-functions are, it just means they're related, and we're going to see how they're related. So it's hopefully, I see some people still writing, but I'm going to move on. That's okay, unless there's objection. I have to kind of scroll past this. So if people do need it, remember, I will post these notes, but I can also scroll back up if you say something. But okay, so we have these co-function identities, right? Co-function identities. And what we want to look at here is, well, this is just alpha. This is theta, as always. And this is a right triangle, right? And then ABC are the sides. So for number 8, it says what function of alpha is equivalent to sine theta? So first, let's just write sine theta is opposite over hypotenuse, which is, if we look at this triangle, it's B over C, right? And this is for theta. Now we want to see, what is this for alpha? Like, what is this? If I'm looking at alpha, the angle right here, what is B? B is going to be my adjacent, ADJ, over C, which is still my hypotenuse. And so this is actually cosine of alpha. And I'll kind of highlight later that, so like what we get here and what we get here, these are going to be the co-functions of each other that we're looking for here. So for example, like sine theta and cosine theta are sine theta and cosine alpha are co-functions. So keep in mind, these angles are different because sine is not equal to cosine. But the angles, when you flip-flop them, that's why they're co-functions, because they, when you change the angles, you can change the trig function and they're equal. So now let's take a look. What function of alpha is equivalent to tangent theta? Well, again, let's start with tangent theta. TOA, that's opposite over, not hypotenuse, opposite over adjacent, which in this case is, let's see, opposite is B over A, right? And again, in terms of alpha, this would be adjacent over opposite. So we flipped it. And so this is cotangent of alpha. And if anyone's not seeing this, let me know, I can stop and kind of just explain. So now we have that tangent and cotangent are co-functions, which kind of makes sense. And then we have our last one. So secant theta is going to be hypotenuse over adjacent, which is little c over adjacent is A. Which is still hypotenuse, but over opposite for alpha. And that means hypotenuse over opposite is cosecant. And now maybe you understand the words, because like secant is the reciprocal of cosine, but it's the co-function of cosecant, which is very weird. There's a lot going on here, but these are functions. This is less important in solving problems as like just knowing sine, cosine, tangent, and then the reciprocals. But it's just, they wanted to point it out, right? Now this last question, how are alpha and theta related? Well, this is a 90-degree angle looking at our triangle, right? And we know that a triangle, all the angles add up to 180, right? So alpha plus theta must equal something. Do we know? Does it? Maybe I should have just said it.
90.
Yeah, there you go. You got it. Yeah, and Ronald, thank you, and David, good. So alpha plus theta has to equal 90 degrees. And it's because alpha plus theta plus 90 has to equal 180. And so we just subtract the 90, right? And these are all degrees, yeah. Which means this implies that theta is 90 degrees minus alpha, and alpha is 90 degrees minus theta. So these are complementary angles. So now we're looking at this next chart is the co-function identities. This chart, so somebody was asking this actually, in office hours, but they were asking like, what are we going to be given certain equations, or do we have to memorize things or anything like that. This chart, you definitely do not have to memorize this. I mean, it's useful to know, but this chart is more just informational. And if you needed it on an exam or anything, you would be given this, because these are weird. These are, you know, it's easy to mix this up, but this is just good for you to know. So these cofunction identities, cofunctions of complementary angles are equal. So what this means, sine and cosine are cofunctions. So sine of theta is actually equal to cosine of 90 minus theta. So I always think of 45 just because I know sine and cosine are the same for 45 degrees. And sine of 45 and cosine of 45, that's 90 minus 45. That makes sense to me, right? But it also works for 30 degrees. So sine of 30 or cosine of 30 is cosine of 60 or sine of 60, right? So if I started like, oops. So I mean, an example here is like sine of 30 degrees equals cosine of 60 degrees. And you'll get into this later when I was talking about that unit circle and you memorize just some of these angles and measures, this is going to be one of them that you will remember. Granted, you don't need to know it in this way, right? Because this is weird, but this is just informational for you and telling you, okay, you know, sine and cosine are cofunctions, tangent, cotangent, secant, cosecant. We saw that, right? Okay. So now we have given cosine, again, we have cosine 75 is square root of 6 minus square root of 2 over 4. Find a cofunction with the same value. So what this means is, first we want to get, okay, so cosine and sine are cofunctions. So we're going to be looking at, so first we want to know this. Sine is the cofunction, right? So cosine 75 degrees, I'm just looking at this right up here, equals sine of 90 degrees minus 75 degrees. Okay? Which means, so 90 minus 75 is 15. So sine of 15 degrees is going to equal square root of 6 minus square root of 2 over 4 is going to equal the same thing. And if you did do this in your calculator, you were curious, you could do cosine of 75 degrees and then do sine of 15 degrees. You should get, there'll be decimals unless your calculator is really nice and fancy and does the square root, but you should get the exact same answer. Just make sure you're in degrees. Otherwise it might look funny. Okay, so now we have some like practice problems here. Are there any questions, I guess, before? Oh, sorry. Somebody said like brothers. Yeah, co-functions. Sure, they're like brothers. I think maybe that's what was meant there. Okay, and Tristan, sorry, you said it's a little bit confusing, but time will fix that. Yeah, I mean, this is true, but also more practice problems will fix it. So if you're confused, like the more problems we do that apply this, you're going to just say, oh, okay, now it kind of makes sense. And then the more you do, the more it should make sense. But please do stop me and feel free to unmute or anything if you have some questions. Okay. So I'm going to go to these practice. So given an acute angle, more of those acute angles, right? Theta, if cosecant theta is square root of 3, evaluate all 6 trig functions just from this. So we can do this. This isn't a problem. We know that cosecant, and again, I'm pulling this from old notes. This isn't, although I know it, it's not like totally at the top of my head, is hypotenuse over opposite. And they told us that it's square root of 3 over 1, right? So this means I can draw my right triangle. So this time I'll do it this way. So I have my right triangle. My hypotenuse is square root of 3. Oh, let's see, where are we going to put theta? Maybe we'll put theta here. My opposite side is 1. So I do not know what this side is, but I need to know in order to get all of these functions over here, right? So let's do a little Pythagorean theorem. 1 squared plus question mark squared is going to equal square root of 3 squared. So, and I'm writing question mark, but maybe I should write this as an actual something, right? Because maybe that's confusing. So we'll call it b, and I'll just say b squared. So b squared is going to equal this right side is 3, and I'm going to subtract the 1 over, so it's going to equal 2. And so then b is going to equal square root of 2. Okay, so this side is square root of 2. We now know what that is. So now, based on where our theta is, we have our hypotenuse is here, our opposite side, and our adjacent side. And we can find all of our trig functions just from this, right? So think SOHCAHTOA. And then you could just flip everything if you don't want to remember anything else. And remember, cosecant, they told us, is square root of 3. I'm not even going to think about that. Okay, so sine is opposite over hypotenuse. So 1 over square root of 3, which if I rationalize, right, is root 3 over 3. Cosine is adjacent over hypotenuse. So what was it? Square root of 2 over square root of 3. Ooh, that's nasty. But we only have to rationalize the bottom. So we multiply, maybe I should write this out. We multiply by square root of 3 over square root of 3. And we get square root of 6 over 3. Right? Tangent is opposite over adjacent. So 1 over square root of 2, which is just root 2 over 2. They gave us cosecant, so I feel like we're cheating, but we're totally not. They gave it to us. Secant, so cosecant, remember, is the reciprocal of sine. So secant is the reciprocal of cosine. So I just know right off the bat, root 3 over root 2. You could say it's 3 over root 6, actually. You could also start, like, you could just start here, right, with this, root 3 or root 6 over 3, and flip that and then rationalize. But I'm going to start with this one here and then rationalize. So I'm going to say, okay, times root 2 over root 2. And then this equals square root of 6 over 2. And then cotangent is square root of 2, or it's the opposite of tangent, right? So square root of 2 over 1, or just square root of 2. Okay. And the reciprocal of tangent, sorry, not opposite. You only rationalize the square root on the bottom. Yeah, so if you have a square root on the top, there's nothing to be done. We just don't like the square roots in the denominator because, well, when you say like a fraction, what is a square root? A fraction of a square root, like that's a bit strange. And mathematicians just don't like that. Okay. All right, so now next up is evaluate all 6 trig functions with theta being pi over 6. So note, something that I didn't say, but it doesn't really matter, I guess, but note that this is not a special, remember how last time we talked about special right triangles? This is not a special right triangle, but looking at this next one, so if this is our theta and it's pi over 6, right? Pi over 6 is the same thing as 30 degrees, which means that this is a 30, 60, 90 triangle. So I'm going to say this is a special right triangle. Not that it really matters, but it helps you. Well, it means that you're not going to use a calculator to find these. You want exact answers, but also because it's a 30, 60, 90. So maybe I'll put like 30, 60. Well, I did not draw this accurately, right? But 30, 60, 90. We know that the opposite is 1, the hypotenuse is 2, and this is square root of 3 if we're in the unit circle, which is what we're assuming. So we know this just from last class. And again, eventually, like you will need to have memorized sine, cosine, and tangent of pi over 6, these values. So you can either do it on the right triangle that I just did, or, I mean, again, based on memorization. So sine of pi over 6, which is the same as sine of 30, is 1/2. Then we have cosine of pi over 6, which is root 3 over 2. And again, I have these memorized, but you could be looking at the right triangle here too. Tangent of pi over 6 is 1 over square root of 3, which is root 3 over 3. You could also look at the, I think we started to write this in the unit circle last class. Cosecant, okay, so this you're gonna flip sine. So reciprocal of sine, which is just 2 over 1, so 2. Secant is flip cosine, so 2 over root 3, which is the same thing as just 2 root 3 over 3. And then last but not least, flip tangent. So the reciprocal of tangent, and that's going to be just square root of 3 over 1. So square root of 3. And this last question here, it's saying given cotangent of 15, find a cofunction. So again, this is just practicing what we just saw. So a cofunction, we have cotangent. So the cofunction of cotangent and tangent are cofunctions, right? So that means that cotangent of 15 degrees is tangent of 90 minus 15 degrees. And so the steps that you're doing here, I mean, you're replacing the function with its cofunction, and then you're replacing the angle with its complement angle. So 90 minus that. And the answer here, the final answer, right, is tangent of, what is that, 75 degrees? Okay. Oh, question? Sorry.
Yeah.
Your audio is pretty tough to, it's like cutting in and out. What does it say after cotangent? Oh, sorry. I abbreviated the word cofunctions. So cofuncs is what I wrote. And why isn't the answer tan 75 equals, sorry. This does equal 2 plus square root of 3, but the question is just saying, find a cofunction with the same value. This is it. So I had put that last time. You don't need to put like that it equals this. Yeah, thank you. German, yeah. Okay, so I'm gonna attempt to save this so that this doesn't, let's see. Oh yeah, go ahead.
Is it wrong to use in here the inverse function?
Is it wrong?
Use in my calculator, for example, I can enter the 2 plus square root of 3 with inverse of cotangent. I mean,
yeah, but are you in degree or radian mode?
but yeah, yeah, sorry, but
Okay.
I don't know if it is tangent or yeah.
Yeah, so I mean, I get you're trying to do
The
the
tangent inverse of the 2 plus square
you're
root
doing this
3.
of 2 plus square root of 3, but if
Yeah.
you're in degree mode, you should get about 75. It might be a decimal, it might not be exact.
Yeah, I got the exact 75.
Yeah, then that should be it. Yep, yeah. But again, we're not going to be focusing too much just yet, remember, on this inverse, because
Mhm.
well, you're doing it correctly, but some people confuse it with the reciprocal part, right? And that's not the same thing.
Okay,
But that works.
thank you.
Awesome. Okay, so now I'm not really sure how to get out of this. Okay, people saw me save it, right? You saw me save this, so it should not. Oh, it even says save to files. Sure, I already did this. Okay, maybe because I wrote something else. Okay, replace. Okay, so that's saved. Oh, phew, okay. So now we want to go jump to 5.3, and this is the section for today, 5.3, and 5.4a. So 5.4 is related to 5.3, obviously, but the professor that did these notes kind of broke it up for us so that she added like a little bit of 5.4, and if we have time, great. If we don't get to it, we'll finish, on Thursday. But then 5.4, if you look back at, 5.4b notes, these will be on Thursday. And we're getting into the unit circle, which is super exciting. And yeah, I mean, that's what we'll get into today. So let's get started. So if you did print this, or if you're pulling it up, this is a separate, right? I separated these, so you should be able to pull this one up as well. And if you have them all in the one big file, we're just moving on, right? Okay, so reference angles. So reference angles, something good to note here. These, we always want them between 0, oh my, why did that happen? Between 0 degrees and 90 degrees, right? And which is 0 or 0 and pi over 2, and that's in radians, right? So we always want this. And when we look at something like this, we know that this is the initial side, and then if we're looking at an angle here, like something like this, if we're looking at theta here, this would be the terminal side. And I'm just like kind of naming, this is initial side. And so a reference angle, so this is a regular, what I just drew in blue, that's like a regular angle that we're kind of used to. But a reference angle is if we had an angle like this that was negative and it went all the way to here, right? And say that was our theta, say that was our angle. Then a reference angle, which we're going to call theta prime, always starts from the horizontal axis, which is really just the x-axis, right? But it always starts, so if it's an angle like this, the reference angle is actually this right here. We don't need a reference angle for the blue one because it's already, well, okay, it would actually be the same as this. But okay, so what this is saying is this green reference angle is actually the reference angle for both the blue and the red angles, okay? I was thinking between 0 and 180, but it's between 0 and 90. So the reference angle is always the angle formed that's less than 90 degrees, that's formed with the x-axis on the left or on the right, whichever side, right? So looking at this green angle, it's actually the same as this angle here. It would be the same, right? Or it's the same if I went down at that angle there. So that x that's already drawn in there, it's showing you that those reference angles, I mean, they're kind of all the same from wherever you're going, but to find it, we always go to the horizontal axis just to find it, based on wherever our angle is. Okay, so we're going to draw kind of a little example here. So for example, if you have on the right, so 0, I'm going to write this in radians, pi over 2, pi, 3 pi over 2, right? So if I have, let's see, a right triangle, and this is like -1, and I draw my right triangle, and then I have +1. Let's see how kind of similar these will be. Okay, something like this, right? So if I have right triangles, I went 1 on like the x-axis, I went 1 and -1. So my length here is 1, and my length here is still 1, but it's just on the negative side, right? If I said, oh, so so in this case, each slice here, is 60 degrees exactly. Or I'm going to look at it in terms of radians. Somebody just commented that it's 60 degrees, but it's going to be pi over 3, right? So each of these, so this angle here is pi over 3, which is 60 degrees, okay? But so is this angle here. Well, okay, hold on. I'm lying. Let's let this, okay, go back. What am I doing? Oh, what I didn't tell you yet. So this angle is pi over 3, but what I didn't tell you is that these sides are different. So this is square root of 3. Hey, sorry, my dog is freaking out. This is square root of 3. This side's going to be 1, but it's negative. So this, like this is -1, but this is square root of 3. Okay, because we want to look at the 30, 60, 90, and then the 45, 45, 90. So maybe this isn't one line. So maybe I drew that a little inaccurately, right? Like this line wouldn't necessarily be connected. But let's just pretend, okay, for now, maybe they're a little bit off. Oh, okay. Yeah. I mean, is someone talking, or someone said you're sick? Oh, and so your camera's not on. Okay. That's okay. Okay. So we know that for 30, 60, 90 triangles, we know all the sides. We know like this side is 1, square root of 3 and 2. And we know that this would be this angle here is pi over 4. And we know the sides are 1, 1, and square root of 2. So my sides are 1, 1, but it's down. So that's why I put that negative, but square root of 2. Okay. So from here, and this pi over 4 right here, it's pi over 4, but it's negative because it's going down. I mean, we could like draw it going up, but it's a negative, let's say. And what I should have done to make this angle better is kind of said, oh, this is like pi over 3 and like 2 pi over 3 or something, right? Because technically, like if this was pi over 3, this was pi over 3, this takes us to this angle, the full angle, which is 2 pi over 3. So I'm just trying to show you, I know there's like a lot happening here, but we're just looking at how angles work, how we can draw this from the center. There's no particular, I guess, problem here, but also to note that we can draw a right triangle from any direction. So like we could have drawn these triangles from a different direction, but if we're told that something is negative, we have to keep this in mind, right? So if we're told that sine of something is negative, well, keep in mind that so technically like this is negative because it's to the left, right? Technically this is down, so there's a negative here. But keep in mind that the hypotenuse, which is this guy and this guy, these are, so hypotenuse is always going to be positive. So like, let's say a problem, we'll look at this. We'll say a problem tells you that sine is negative. Well, that means the opposite, like sine is opposite over hypotenuse. So the opposite side has to be negative. So if you're going to draw this, you'll know where to draw it based on that. That's kind of just what we're looking at here. And there's no particular problem, except, okay, maybe this will relate to the problems we do now using reference angles. So maybe I should have started with that. So here we want to use reference angles to find the exact value. So sine of 2 pi over 3, like for example, we know sine of pi over 3 or pi over 6 or pi over 4. We know all of those, 30, 45, 60, right? 90. But 2 pi over 3, right off the top of my head, I wouldn't know. But to know that, that's where, actually, that's exactly where this comes into play. This that I was drawing up here, I'm highlighting it now. This is 2 pi over 3. Okay, so I'll highlight that again. So this whole angle here is 2 pi over 3. And the reference angle, Scooby, stop. And the reference angle is the angle that I drew here, is pi over 3, right? Because the reference angle has to go from the horizontal axis. So what this means is 2 pi over 3, this angle, it's in this quadrant. So the point is here. So I know that sine in this case, like here I have the x-axis and the y-axis, I guess. And I know that sine represents like y, so it's going to be positive here. Okay. I'm so sorry about the dog. Hopefully he stops soon because I can't. Okay. So we know that sine of 2 pi over 3 is going to be the same thing as sine of pi over 3, but we just have to check the sign. We have to check the SIGN, right? The plus or minus. That's what I'm talking about. So sine of 2 pi over 3 equals the same thing as sine of pi over 3, which is, I know from my chart that I have memorized, right? That you don't need to have memorized yet, but you will, is root 3 over 2. So now cosine of this is where it gets a little tricky. So this point right here is, I went all the way. This is 2 pi over 3, right? This is theta is 2 pi over 3. And I drew my line to my point. And this is where this point is going to be, well, I know that root 3 over 2 is the sine, and the cosine is 1/2, but it's negative here because my x, I'm on the negative side of my quadrants for x. And so what's going to happen is cosine of 2 pi over 3 is equal to negative cosine of pi over 3, which is negative 1/2. So I'm looking for, if you didn't have a calculator for these, I'm looking for a reference angle, and then I'm making sure the sign is correct, the SIGN. So because if you just made it the same as if you thought of cosine of pi over 3, so pi over 3 was this guy here, right? This was pi over 3 right here. Right? And if I take this point, this is 1/2 square root 3 over 2. So it's the same as this point here. Like this point and this point are the same, but what's different is that the x is negative and the y is positive. Or both y's are positive, right? So now in part C, we want to look at the pi over 4. So this is what I was kind of drawing. I was prematurely drawing this. So I have negative pi over 4. That's this blue that I already drew here, right? And the reference angle here is actually just still pi over 4. But we just have a negative sign. So we have to be aware that in this quadrant, I have what's positive, what's negative. Well, my x is positive, but my y is going to be negative. So if I'm doing a tangent, I should get a negative value because remember, tangent is sine over cosine. So in this case, what I would do is I would get for pi over 4, at this point, it's root 2 over 2 and root 2 over 2. And so if I divide those, they're the same thing. So I get negative root 2 over 2 over positive root 2 over 2, which would just mean negative 1. And the way that I know these points is, well, okay, I'm writing them as points. You could be thinking of them as opposite over adjacent, or opposite over hypotenuse, or because I drew the right triangles, right? So here you could be thinking of these whole things as, you know, opposite or adjacent or hypotenuse or whatever. You could be thinking of it that way if you're confused about the points. We're going to get to the points today and kind of how I got that, and we'll have a little chart for you guys. Okay, so now I have some room because we're going to draw some things here. So cosine is 7 pi over 6. I need to figure out where that is and what my reference angle is, and then I can figure this out. So let's see, 7 pi over 6 is, well, 6 pi over 6 is just pi, right? So this is 0, pi over 2, pi. So pi is the same thing as 6 pi over 6, which means 7 pi over 6 is just slightly more. So it's like somewhere here, this would be 7 pi over 6. Okay, somewhere there. So if I wanted to draw this right triangle, I would say, okay, 7 pi over 6, the reference angle, this angle here is pi over 6. So I know that this is related. If I look back at these triangles, it's related to this triangle. So I can label it with those sides. So that's what I'll do for this one. Like the opposite of, but keep in mind that the pi over 6, oops. Keep in mind, pi over 6 is up here in the triangle above. But in our triangle here, pi over 6 is down below. And maybe I should, well, I wish I could make that a little bigger. And then this angle here is pi over 3. Okay. So I want to label this triangle. So I'm going to label the opposite of pi over 6. I'm looking at that. That's going to be a 1. But in this case, it's negative just because of where it is on the X and Y axis. And then the hypotenuse is 2. And the adjacent side is square root of 3. But again, this is negative because of where I am on, think of this as just an XY axis also. So remember, like here, if I'm thinking of X and Y, they're both positive. Here, X is negative, Y is positive. Oh shoot, Y is positive. I don't know why I did that. So this should be plus square root of 3. Here, X is negative, Y is negative. And here, oh, this is right. This is right. Sorry, I was thinking Y. Negative, negative, and positive, negative, right? Oh yeah, somebody, thank you, Michelle. All students take calculus is a good way to remember. And yeah, Jakob, you can just remember, that's good. But yeah, so this here, now we have our right triangle, and I just want to find cosine. So now actually I made it pretty easy for us because we don't even have to think about the reference angle. We can just say, what's cosine? Adjacent over hypotenuse. So negative root 3 over 2. And we're done. So I was making it complicated by writing the point in there, but it'll be more relevant later. Sorry, 1 second, class. Zipper pocket in my backpack. Scooby needs a while, probably. Okay. Okay. So now let's do sine of 135 degrees. So for those of you that didn't like radians, we're switching back to degrees for a minute. So 135, I know it's between 90 and 180. So if I draw this, it's like somewhere, and again, it doesn't have to be perfect, but it's somewhere in there. This is 135 degrees. And then I'll make my right triangle with it. Okay. Oh, was there a question? Sorry. Oh yeah. Okay. So so thank you, Jakob. So the reference angle here is 45 degrees. And the way that you find that is just 180 minus 135, right? You can figure that out. And so when we get this here, we know that it's a 45, 45, 90 triangle. So this side is 1, this side is 1, and this side is square root of 2. But we have to make sure like we have to look at our pluses and minuses, right? What's positive, what's negative? Well, this is negative, but this goes up, so this is positive and everything else is good. Okay, so we just had to do that. So now, sine of 135, sine is SOHCAHTOA, opposite over hypotenuse. So 1 over square root of 2, which is root 2 over 2. And if you can find these as well, or if you're like good at this, I mean, feel free to do it. And if I make a mistake, please let me know, because that has definitely happened. It happens more in my in-class or in my in-person class, but it'll happen here. So just try to get yourself ready. Okay, now we're gonna look at the next one. So I'm gonna write 0, 90 degrees, 180 degrees, 270 degrees. And oh shoot, I should have done negative. So let's now also do negative. So 0 degrees, negative 90, negative 180, negative. Okay, so I know negative 120 is going to be somewhere in between here, right? So let's draw that. Let's see. It doesn't really matter because it doesn't have to be perfect, but let's just pretend it's there. And this is negative 120 degrees. I can draw a right triangle and say, okay, this reference angle is going to be 180 minus 120. So 60, right? So this is going to be 60 degrees. So it's a 30, 60, 90. And I know that triangle looks like this. The one is adjacent. If you're not sure what it looks like, again, I'm taking this from notes that we did the other day. And this is square root of 3. So now I have to remember, okay, this is a negative 1 because it's to the left of the x, of the 0 on the x-axis. And this is negative root 3 because it's down. It's going down. Okay, so now we have a right triangle, and we can say secant of negative 120 is, ooh, what is secant? Secant is the opposite of cosine, so it's hypotenuse over adjacent. Okay, sorry, that took me probably way too long, but hypotenuse over adjacent is 2 over negative 1, so it's just negative 2. Okay, I'm going to scroll a little bit here. So let P20 negative 21, this is a point. It's telling me a point, and this is like X and Y. So it's saying, okay, let that be a point on the terminal side of an angle theta drawn in standard position. Okay, sure. Find the values of sine theta and cotangent theta. So 20 negative 21 means X is 20. So like that's going to be somewhere there. And negative 21 is going to be like somewhere there. So I'm just making up this point, right? But I know that it's in the positive, it's in quadrant, 4, right? Because X is positive, Y is negative. So this is the point 20, negative 21. And now I can construct my like right triangle. And I know that this is 20, my Y is negative 21, and I don't know my hypotenuse, but we can find it, right? We can do Pythagorean theorem. And my angle, so it says it's a point on the terminal side of the angle. So my angle could, I mean, just go this way, and it could be that, but it could also go backwards and be negative and be something like this, right? So it doesn't really matter because we were given two of the sides, and we can use Pythagorean theorem here, and then just use SOHCAHTOA. But I'll just say could be either angle drawn here, I guess I'll say, right? Because standard position, well, there's one standard for positive and one standard for negative. So we could go either way with the terminal side being there. So in order to find, so remember my theta, I mean, theta could be here. It could be wherever. It could be the blue one. It could be the green one. And maybe I should write those in blue and green. So it could be this one, and it could be this one. But in order to find this, we need to look at this triangle and think of the angle as if it's here, so the reference angle, and then just do SOHCAHTOA to find, what do they want? Sine and cotangent. So sine theta and cotangent theta. And to find these, well, I know this is opposite over hypotenuse, and cotangent is adjacent over opposite, I think, right? Okay. So to do that, we just need to find the third side because we need the hypotenuse. So let's just do a little quickie Pythagorean theorem here. So I'd have, this is the hypotenuse, and I don't know it. So I have 20 squared plus 21 squared equals c squared. And that's going to be, this is 400, this is 441. So this is 841 is c squared. And this actually comes out to be nice. This should just be 29. So this side ends up being 29. Yay. So that's kind of easy for us. So then opposite over hypotenuse, again, is negative 21 over 29. And then adjacent over hypotenuse is 20, or adjacent over opposite, sorry, is 20 over negative 21. But I could just put the negative in the top. Even though the 20 is actually positive in my triangle, like in my little trig diagram, the negative can, it doesn't need to, like, it can go in the denominator, but that's kind of weird. We don't, like, if we have negative 1/2, we don't write or say 1 over negative 2, you know, like we don't say it like that. But it doesn't matter as long as you have that negative there. Okay, so moving on to another example here. We have secant is 41 over 40. So remember, I'm just gonna kind of highlight this for us. Remember, this means secant is hypotenuse. It's the opposite of cosine, and this is adjacent. And theta is in quadrant 4. Okay, this is where, like, 1, 2, 3, 4, the quadrants are going to matter. So it's in quadrant 4. That's important. Find tangent and sine. Okay. So what this means is that we have something like this, right? My theta is in quadrant 4. So that means, and my adjacent is 40. So let's see. So somewhere in here, we don't know where, but I'm just going to make a right triangle. We know that theta, you know, is somewhere in quadrant 4. It might be going this way. It might be going this way. Doesn't matter, but it's there. And then we know they give us the 40 and the 41. So 41 is here, 40 is here, and we need to calculate the other side. So we got to do a little Pythagorean theorem again. So I'd get 40 squared plus b squared. We'll name this b. We don't know equals what. Equals 41 squared. So this time we kind of just did use these numbers, but I think, right? Oh no, it was 20 and 21. Oof, no, just kidding. Okay, so b squared is going to be 41 squared. I'm not going to write out the whole number partially because I'm being lazy, but 41 squared minus 40 squared, which this is nice. This is just 81. And so b is 9. Okay, yay, so b is 9. And now we just want to find tangent theta and sine theta. And so we can just use SOHCAHTOA here. But keep in mind, ooh, I made a mistake. Well, not a mistake, I'm forgetting something. Yeah, okay, German, you caught me here. This is a negative 9. So when we solve for the Pythagorean theorem, it's always positive because in real life, I mean, when we're calculating these things, triangles, lines, they're positive, distance is positive. But in this case, when we're doing trig, we can get negative numbers based on what quadrant it's in, right? So in this case, do not forget, I was about to forget it and it would have been wrong. So thank you, German. It is going to be negative 9 here because it's going down. So keep in mind, this is in quadrant 4. That's why those signs that I was doing before, plus, plus, minus, plus, minus, minus, plus, minus, that is so important.
Isn't cosine isn't positive in the fourth quadrant?
Cosine is, but the negative, the 9 sine will be negative, right? And tangent will be negative. So cosine, like they gave us secant, which is the reciprocal of cosine, and it's positive. So that's why I was kind of just forgetting and would have left it off. But they told us that theta is in quadrant 4, which tells us that this side has to be negative.
Okay.
Yeah, by drawing our right triangle. Yeah. So now we can just use SOHCAHTOA and get these. So tangent is opposite. So at this point, let's label. This is hypotenuse, this is adjacent, and this is opposite side. So tangent is going to be -9/40 because it's opposite over adjacent. And sine is going to be opposite over hypotenuse. So -9/41. Okay. Okay, so this next word, I'm not a fan of quadrantal or something, but this just means the angles that are on the actual like sides of the quadrant, I guess. So like 0, 90, 180, like the ones exactly there. Section you're currently, yeah. So sorry, Joseph is asking what section is this? This is 5.3. Towards the end of this, it combines, or maybe even, yeah, I think towards the end, it combines some of 5.4 when we get to the identities, but then this will, like, then we'll continue 5.4 in the next section of notes. Yeah, okay, cool, thanks. All right, so let's take a look. I already lost myself here. Okay, so we want to find sine, cosine, and tangent for theta is 90 degrees. So, okay, we know that this is 90 degrees, you know, that angle is 0 degrees. And we want to find, I mean, if we drew a triangle, well, the triangle's not going to necessarily work here because our theta can't be 90, or like when we draw the triangle, like, because we can't draw a triangle like this. It has to be a triangle coming with forming a right angle with the x-axis that has like a point here, right? So we can't really do that. So to find this, we can look at angles as they're approaching, but and maybe that's what I'll talk about. But we also kind of know this already. So because this point on the unit circle up here is 0, 1 when it's on the unit circle. So just to answer the questions here, sine of 90 is going to be 1. Cosine is going to be 0. And tangent is going to be, oh, let me scroll down, is going to be sine of 90 degrees over cosine of 90 degrees, which is 1/0. But can we divide by 0 is the real question. And the answer is no. So this is going to be undefined. This is not going to exist. So when we graph, you'll notice if you ever have seen the graph, if you Google graphs of tangent functions, there's a dotted line, there's an asymptote, like a vertical asymptote, and it's at 90 or pi over 2 and all the multiples of this, because we're dividing by 0 and we can't do that. But a way to think of this, if you really wanted to, is if we were drawing a bunch of like right triangles, and we were getting closer. So like then I go up here. Okay, that's not a great right triangle, but you get the picture. And then I go really close and draw a right triangle. So as I get like move closer and closer to 90 degrees exactly, these values, I'll just write this out for you. So as the angle here, like this angle here, approaches 90 degrees, and we'll call this like so say this was B, you know, like A B C, like C C B A. Okay, so say like in our in our, like all of the sides there are B. So the side that we're calling B here gets closer to C, because C is my hypotenuse, right? C is here, B is this one. They're like almost identical. And then if we could draw, I mean, we can't, but if we could draw a triangle here and have it be like a right angle exactly right there, it's really just a line. But if we had a really thin triangle, B and C are really, really close together, right? And A, your other side is really tiny. So the point is they're getting closer. So what's happening here, or what we say, is that B over C approaches 1, because they're and this arrow just means approaches, because they're getting so close together. But then it's not a triangle anymore, but that's not the point, I guess. And then A over C and A over C approaches 0, because A gets closer and closer to 0. Because if we look at A, you know, the first time it's this whole thing, then the second time for the red triangle, then the second time it's just that, then the next time it's just this little piece, right? Then it's getting even smaller and smaller and smaller and smaller until we can't see it anymore, right? And is the radius 1? Yeah. So in this case, we're looking at a radius being 1. So that's why like this point right here is 1. Yeah. Okay, cool. And I just wanted to mention that. That's not a big deal. You don't need to really know that, but just if you're curious, like why that's happening. Okay, let's take a look at the unit circle. So now we're looking at the unit circle. We're being told the radius is 1, right? Which was just asked. So we are being told that. And we know that, well, this is the equation. Like if you wanted to know what's an equation of the unit circle, x squared plus y squared equals 1, it is an equation. So, and if you remember equations of circles, 1, like this number, is the radius squared, which in this case is still just 1, pretty boring. But that means if we take any point on this line and we draw a line to the center, the distance is 1. And we could even drop this and do a right triangle, and then we have a point like what I was kind of drawing earlier. I was getting ahead of myself, and this point represents x and y values, but also sine and cosine values, which is kind of cool. So number 5 says, show that the point negative square root of 3 over 2, comma 1/2 lies on the unit circle. To show this, we are going to use this right here, right? We're going to use this, this formula. So I have an x, well, and this is my x and y, right? So this is our x, this is our y, or maybe I should label it here, x, comma y. So I'm going to have negative square root of 3 over 2 squared plus 1/2 squared equals c squared. I mean, I can do this as if it's a right triangle, or I can just say equals r squared or something like that, right? But we'll do we're going to use Pythagorean theorem here. Pythagorean theorem. And think of it as, you know, like this is negative root 3 over 2. This is 1/2, and this is 1. Well, okay, we don't know that it's 1 yet, but this is our right triangle, okay? And so when I calculate this, I get, when I square this one, I get square root of 3 squared is 3, 2 squared is 4, and then 1 squared is 1, and 2 squared is 4. So I get 3/4 plus 1/4, 3/4 plus 1/4, and that will be just 1, and that's c squared. And so c equals 1, and it's got to be on the unit circle, because if the hypotenuse equals 1, then we're on the unit circle. So we're good to go. And now we're going to use the definition of unit circle, which I've kind of been alluding to this, or even maybe speaking about it without actually going through it with you guys. So I apologize if that's been confusing. And I forget who it was. Maybe it was Tristan that was like, none of this makes sense. But maybe it will all start to make sense now that we're actually kind of going through step by step this trig circle. And if we're okay with this, I'm going to scroll to the next page. I think most people seem okay. Stop me, please, if you want me to wait. Okay. So here, this P right here, this is a point. It's saying it's a point, right? That's just what P is. And then X, we know, we know X, the XY axis, we know a point, X coordinate, that matches cosine of my arc length or my theta, which is, in this case, we're saying T. Then there's my Y, which matches sine of T. So every time I've been referencing this, that's what I've been talking about. So if I drew a right triangle, I line to the center, drop it down, make a right triangle, right? If I do this, my X value is here, my Y value is here, right? Because X is how far you go left or right, Y is how far you go up or down. And then I know that my hypotenuse has to be 1 because I'm on the unit circle, or at least that's what we're assuming this is the unit circle, right? So if I have this triangle and maybe I make, this theta, okay, okay, theta or T, but in this case, we're looking at the arc length here. So it's the same thing as, it's going to be the same thing as what theta is with this angle right here, okay? Okay, so if I draw this out a little bit like bigger, I guess that's what's going on. So what's going on here, this is just being drawn a little bit bigger so you can see it. So again, we have X is here, right angle, Y is here. My theta is this angle inside here, right? This is theta, and they did that over here as well. So what we're looking at here is that my cosine theta, so cosine theta is going to be, if we're looking at SOHCAHTOA, it's adjacent over hypotenuse, X over 1, so it's X. Then my sine theta is opposite over hypotenuse, which is just Y. So that's how they're getting this type of thing. They're using T, the arc length, but we'll end up, okay, so X equals, we can use T or theta. So X equals cosine T, Y equals sine T. So we can use either, okay? I think a lot of times we'll be using T, but T can represent the angle or the arc length, because in this case, they are going to be the same. So it says, so looking at this, an actual problem to solve here, right? Suppose the real number T corresponds to the point, and I guess, well, okay, T is corresponding to this point. So T is the arc length to get to that point that we're looking at P. Later, we will specifically use theta, but it's all going to represent the same thing. So we have this real number T, it corresponds to the point P. And this is the point. So remember, this is our X, this is our Y. So X is 5/13. So that's like, okay, so say the unit circle is 1. So 5/13 is going to be, I don't know, like somewhere in here. And then -12/13 is really close to 1, but it's negative in the Y. So maybe it's like somewhere down there. So we might have a point like right here, if this was like -1. Okay, so here's our point P. And I can create a right triangle with this point. Ooh, that it doesn't look perfectly right, but I can create a right triangle, and I know that this is 5/13, and this is -12/13. Right? And this has to be 1 because we're on the unit circle. So like if this circle was to be made, the radius would be 1. That circle actually came out kind of nice. This won't always happen. So what we want to do is find sine, cosine, and tangent, right? So sine of T, they told us it's just the X value. So, I mean, oh my God, there's the y value, right? So sine of t is y, which is negative 12 over 13. Cosine of t is x, which is 5 over 13. Very cool. And then tangent of t. Now you can either use SOHCAHTOA, I guess here, or it tangent is sine over cosine, right? So technically it's y over x. It's probably easier, well, either way, SOHCAHTOA works here, but it's y over x. So my y value was negative 12 thirteenths, and my x is 5 thirteenths, right? And so again, this is like negative 12 over 13 times 13 over 5. And you could either just cancel the 13s right away or realize that they're going to cancel here. And our final answer here is going to be negative 12 fifths, right? Oh, sorry. I should have circled all of these. But tangent is the only tricky one here because sine and cosine are just x and y, or y and x, right? Now, just as a note, you'll see this later, but the triangle 5, 12, 13, like the right triangle, this is a special right triangle. And we may have already saw it or we'll see it later, but if you do the Pythagorean theorem here, this works out like 5 squared plus 12 squared equals 13 squared. But what's kind of crazy is that if we're on the unit circle, look what happens. Oops, whoa, I can't write. When I just divide everything by 13, I get exactly the triangle that we were looking at here because this is just 1, right? So kind of cool that from these special right triangles, we can actually form triangles in the unit circle or other random triangles that have numbers that look weird, but they're actually made from something like that was very specific. Okay, just something to note. Like this is like a side note. Okay. Oh, and sorry if that people are still waiting there. Okay. So now we're going to evaluate trig functions using our unit circle. So, and again, I was doing this like I was just doing this, I don't know, unbeknownst to me earlier. Like I can't think of the word that it's called, but I was doing this earlier by accident, even though you guys may not have known what I was talking about. So let's take a look at this. So we want to identify the ordered pair on the unit circle that corresponds to t equals this. Oh, okay. And then we're going to evaluate sine t and secant t. Okay. Keep in mind, unit circle means that hypotenuse always equals 1 when we draw our right triangle. And t is negative 5 pi over 6. So when I have 0, this is radians, but negative pi over 2, negative pi. So negative pi and negative 5 pi over 6, they'll be very close because negative pi is like negative 6 pi over 6, right? So it's going to be somewhere here. So this is going to be negative 5 pi over 6.
So in this case, t doesn't correspond to the sector.
Yeah, in this case, well, so it does, but so in this case, and I kind of drew that poorly, but it's something like this. It's the sector, it is, so it's the sector on the unit circle. So if this was 1 and I had my unit circle all around, the sector is from here to here, this sector is 5 pi over 6. But we want to focus on the angle because now we're going to do a little right triangle trig and check out the unit circle but it does associate with this sector.
Do you mean like the length, or do you mean?
Oh yeah.
Yeah.
So not okay, not the okay. So thank you. It the like the arc length, it is not that because that's
Right.
well
That's I
actually
should
it
have
is
phrased it better.
okay, but so okay, T so S equals R theta. This is arc length. But in the unit circle, R is 1. So unit circle, sorry, I should have said this way earlier. S equals theta because R is 1.
Okay.
Okay. So whenever I say T or theta, they're actually, I mean, okay, maybe this should be a T, right? Like T equals R theta. But either way,
Oh, so it's just like a variable.
yeah,
It's not
yeah,
like a
yeah.
okay.
It's not it's not, yeah, and it's
Not
not
a
anything
fixed thing.
fancy. Yeah. It's just they're using they don't want to write sign S. Like if we were writing S, that'd be like, why are we, what is S? You know, like that's weird.
Right, right.
So they use T instead, which I mean, I prefer theta, but yeah, it's the same thing.
Okay.
Okay.
Thank you.
Yeah, good question. So now we have something like this, which if I'm in the unit circle, I know this is just 1 because for anything in the unit circle, this is 1. But if I want this to if I want to use my reference angle, so if I want to use this angle here, right, as a reference angle, then my triangle, my right triangle would extend a bit and it would actually be well, I'm going to show you this, but my right triangle would extend and this side would be 2. This would be square root of 3 and 1. This would be this would be, the reference angle is pi over 6. So this is a 30, 60, 90 triangle, but it's not contained in the unit circle. So that's why it's not really related. But oh yeah, somebody said they found it. Yeah, you're correct. But so this point here is going to be, you know, if we extended it like this, we could use right triangle trig with pi over 6 as the angle. But if we kept it on the unit circle, we're going to look at this point on the unit circle, and this point P is exactly what Jakob said here. It's going to be square root 3 over 2, comma, negative 1/2, or negative square root 3 over 2 and negative 1/2, because technically these are both negative, right? Because we're in the third quadrant. But if you look at this, if we divided this by 2, this by 2, this by 2, we go from our right triangle trig to unit circle. And that's pretty cool. I was just trying to show like that connection, but it's not as important. What's more important is getting this point on the unit circle and showing that this point here, now we can find sine, or maybe I shouldn't write this. Now we can find sine of t and secant of t. And sine is just going to be my y value, so negative 1/2. And secant is 1 over cosine. So as Jakob said, cosine of t is negative root 3 over 2. But if we flip that, it's going to be secant. So 2 over square root of 3. Keep the negative. Doesn't matter where. But then we have to rationalize, right? So negative 2 root 3 over 3. So these are our answers here. Okay, and the next page is going to be kind of my favorite, I guess, because we're just going to write all of the positive and negative, like what I was trying to do earlier, but it's a little bit more organized. Okay, so I can scroll back up if people need it, but I'm gonna move on here. So trig functions in the unit circle. So this is where, all right, we'll start with sine, and we have, let me just write all the quadrants. So like 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay. So I just wanted to get all the quadrants out there, but now we'll do sine first. So sine, remember sine is like the y value. So it's positive oh my gosh. Okay, sorry. It's positive above the x-axis. So we have it's always positive here, but it's negative and negative here. Then we have cosine, which we'll do here, which is the x value. So it's always positive to the right of the y-axis. So it's positive here and positive here, because that's where x is positive, right? Negative here, negative here. And then last but not least, we have tangent. And this is sine over cosine. So I'm going to just kind of write what it is here. We have like plus over plus, because they're both positive here. So it's positive in the first quadrant. Then we have plus over minus. So it's negative in the second. Then we have minus over minus. So it's plus here. And then we have minus over plus. So it's minus here. So it's kind of positive in the opposite, like 1 and 3 quadrants, and negative in 2 and 4. And if you get into calculus, derivatives, this type of thing, tangent is also it also represents slope, which is like rise over run. So if you just look at like little points here, and we just drew a line here, this has a positive slope, right? Positive, positive. And if I draw a little line here, right, this has a negative slope, negative, negative. So it's another way, just something interesting to connect there, that like based on the line, like tangent comes back and is related to slope when you get to like calculus and things. Okay, so I love that. I was trying to kind of do this in my head earlier, what I just wrote up there. And so this will be helpful for you just to remember the signs, right? So for problem 8, it's asking find 2 angles between 0 and 2 pi for the given condition. So what this means is there's going to be 2 angles here that have this value. And what are they? And we want to do it in radians here. So again, you could do it in degrees and convert, but up to you. So root 2 sine is root 2 over 2. I know that, well, in my head, I know 45, which is pi over 4. So I know like pi over 4 is one of them, where it's going to be root 2 over 2. But then if it's pi over 4 here, and I'm looking at sine, which is the y value, so it should match over here. So we want to figure out what is this other angle, because they should both be root 2 over 2. But we can't look down here, because sine will be, sine will be negative in those quadrants, right? And so we don't want that. So we want to look where sine is positive, and it's going to be at pi over, it's going to be at pi over 4. And this green angle that I kind of drew here, that's just going to be, so if you think of it in segments of like 1/4, we have pi over 4, then up to this is 2 pi over 4, then we'd have 3 pi over 4, and then 4 pi over 4. So it's 3 pi over 4. And we always think of this in terms of like fractions of pi. So whenever it's 1/4, it's like splitting it up. 1/4, 2/4, which is a half, 3/4, 4/4, which is a whole, and then it keeps going. Next one is tangent is -1. Okay, so we want tangent to be negative. So if we just look above, we know that it has to be either in this quadrant or actually we're looking for 2 angles. So it's in quadrant 2 and in quadrant 4. So we already know the quadrants. We just have to figure out where, this quadrant and this quadrant. And we have to figure out where in those quadrants, right? Oh, my bad. This quadrant and this quadrant. We have to figure out what this angle is, right? And so this angle here and, this angle here, because they don't want negative. They want between 0 and 2 pi. So no negative angles. So let's see, the first angle we get is going to be, So I know that tangent is sine over cosine. So I want a place where sine and cosine are the same, and it's actually at pi over 4. Like my reference angle is pi over 4. So I always think of this angle, but I want to find it here, right? So it's going to be the same thing we did over here. It's going to be 3 pi over 4. So my first answer is going to be 3 pi over 4. But then my second answer is this longer one, right? Going all the way here. So again, if you divide this into fourths, it's like 1 pi over 4 is here, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. So that's what this is going to be. Or you could have just gone 1 back from 2 pi, which is 8 pi over 4. Right? So this is going to be 7 pi over 4. And again, like we didn't want it in either of these quadrants because it was negative there, or it was positive there. Last but not least, we have cosine here, and it's negative. So again, let's look at this. Cosine is negative all here. So we know it's not going to be in the positive quadrants. So we know that it's not going to be here, and the two angles are going to be somewhere in these quadrants. So one of them will be somewhere here, one will be somewhere here, right? I'm drawing lines that are not precise, but they'll be somewhere in there. So I want to find an angle here. That's the equivalent that has the cosine of square root of 3 over 2. And then I want to find one here that has the equivalent to square root of 3 over 2. So for me, I always go back to that reference angle. And technically the reference angle is this. So I have to think, or it's whatever's in the first quadrant. I have to think, what is the angle that gives me square root of 3 over 2 for cosine? And it's going to be pi. I always forget if it's 30 or 60, but it's going to be 30. So pi over 6. So it's, oh, what's up?
I mean, 150 degrees.
Yes, but we want radians, right? So yes, you are correct. But we want radians. So that's going to be, if it's pi over 6 normally, and we want to go to 150 instead from 30, we just add. So it's going to be 5 pi over 6. So 5 pi over 6 is this first one, this first one here. It's almost, so I drew this very inaccurately, but it's almost 6 pi over 6, which is pi, right? 0 pi over 2. And then the next angle is going to be, again, some type of pi over 6, but actually we know that this reference angle, it's pi over 6. So if this is pi plus pi over 6, it's just going to be 7 pi over 6 to stay in that quadrant. And again, I mean, if you Google like a unit circle, you can actually use the unit circle. You can use a unit circle like when you're doing all of this. And I recommend having it in front of you, fully labeled, like print it out, write it down. Actually, if you write it yourself and fill it in, there's like a very low chance that you'll forget any of this. But I recommend having that unit circle filled out. Like what I'm talking about here is something like this, like a unit circle 1, like something like this. And then with these filled in. So this is like 30, 45, 60, then we have 90, and filling out like all of the angles, but then also filling out, and we're going to do this later. Like I'll get a nice one for you, but you can Google this now just to have. But then like 30 is the same thing as pi over 6. This is pi over 4. This is pi over 3, pi over 2, right? So you can have this look really nice and have it just every class looking at it, and when you're doing homework, because I think it'll just help. However, okay, what I wrote here is like chicken scratch and not great, so I will. But we will make a nice one at some point. We just aren't doing it yet, right? Okay, so the last problem on this page, sine of theta is negative square root 55 over 8. So I have no idea what that really means, but okay, so they give us sine of theta is negative square root of 55 over 8. And cosine is negative. So, okay, so I know that sine is negative, cosine is negative. Find cotangent and cosine of theta. Oh, okay. So, and maybe I shouldn't write it like this. I mean, you can keep it like that, but sine is negative, cosine is negative. I don't know if that was confusing with like a minus or words, but okay. So if we look back above and we want to find what quadrant is sine negative, but cosine's also negative. So look up here. Sine is negative here, cosine's negative here. They overlap in this quadrant. So we already narrowed it down. It's going to be quadrant 3. So if I draw myself a little graph here, I already know that it's not in any of these, and it's going to be something in this quadrant. Okay. And my angle is, oh, well, we don't know the angle. So the angle could either be this way or this way. It doesn't matter. But we can make a right triangle because they gave us this value. And we know that this is opposite over hypotenuse, right? And remember, hypotenuse can never be negative. So this is just 8, the hypotenuse. The other side is negative square root of 55. And then we don't know that side yet, but we can calculate it with Pythagorean theorem, right? So let's do that. And let's see, so we'll get, let's call this side just A. So we'll get A squared plus square root of 55. And I'm not including the negative, but you can because it goes away, equals 8 squared. So A squared plus 55 equals 64. A squared is going to be, I subtract from both sides, 9. Oh, nice. Okay, so A is just 3. But remember, it's negative 3, right? Because it's cosine is negative. Right. Okay, so now we have our triangle. Doesn't really matter like this. And then, I mean, this would be like the reference angle, but it's going to be the same as the others. So we have our triangle. We know all our signs. So now we can find what they were asking. So cotangent theta and cosine theta. Cotangent is adjacent over hypotenuse. So that's going to be adjacent is negative 3 over hypotenuse is 8. Right? So I get, oh no, that's wrong. It's adjacent over opposite. What am I saying? Okay, don't listen to me. It's obviously close to bedtime, right? Okay, negative 3 over negative square root of 55. So the negatives cancel each other out and we rationalize. So 3 square root of 55 over 55. That's our final answer there. And then cosine is just, here we go. This is just adjacent over hypotenuse. Maybe that's what I was thinking of, negative 3 over 8, and we're done. Super. I am going to go through the identity on the next page, just the first part, and then we'll do problem 10 to start the next class. All right, maybe I could even do it. Let's see. Because then we can just start clean with a fresh set of notes next class. But maybe I'll save it. So back to our identities, our Pythagorean identities. I'm kind of like pausing in case people need this page, but okay. So back to our Pythagorean identities. We think of the Pythagorean theorem. Right? And it's like a squared plus b squared equals c squared. But in this case, when we have the unit circle, we're gonna well, this is like technically x or whatever a, but x is cosine theta, y is sine theta. So this is also x squared plus y squared equals 1 in our specific, so for our specific example. So like our example is this, right? And then we can replace x and say cosine theta squared plus sine theta squared equals 1 also. So, and you can write this if you don't like the parentheses, and maybe this is better. So this is the first main trig identity, which actually just shows up right here. And then if we
Symbol
divide,
in the middle.
sorry,
Yep.
go ahead.
You have cosine squared theta equals.
Oh my
sine
gosh.
squared theta.
Thank you so much. Clearly we are going to save the rest after this. Thank you so much. So if we divide, okay, and I have cosine and sine, you can flip them, but if we divide everything here by cosine squared theta, we get this one. We get tangent squared theta plus 1 equals secant squared theta. Then if we divide everything by sine squared theta, then we get 1 plus cotangent squared theta equals cosecant squared theta. So like if we follow this, if we divide here, we get this one, right? And then if we divide by this, we get this one. And the main one is this guy here. And you should memorize the sine squared plus cosine squared equals 1, but then you don't need to memorize anything else because you can get it from just dividing or like rewriting. Okay. Okay, and so I'm gonna save problem 10 for the next class just because I feel like I always end late or right on time. And so the question of the day before you leave is going to be, let's see, give me your favorite flavor ice cream. And maybe I'm gonna go out and get some. So, okay, so give me your favorite flavor ice cream. And I'll stick on for like 2 or 3 more minutes if people have any questions. But otherwise, have a good day, and I'll see you Thursday. Yeah, Joseph, go for it. Yeah, so although there is a recording and I did figure out like where I can access it, but ACC records everything just for quality assurance or whatever, I don't know, purposes. But the reason I actually cannot post recordings or anything is because this class is online synchronous, which means you have to be in attendance in class in order to have access to the lecture and things. But there are other classes that ACC offers that are like distance learning where they're just recordings and you could go at that time, or the professor could record whenever they want and then post the lecture and you just watch it by Tuesday at this time, so our class is like that. And yeah, thank you. Someone asked, is anything due tomorrow? Yeah. So there is the syllabus quit? No. Was there that like initial assignment? I haven't checked Blackboard. I'm so behind. But that initial assignment, I don't remember when I made it due. Is it due tonight? Probably. I should have said this. Yeah. Oh, initial assignment is due tomorrow. So the homework assignments are all due starting September 4th. So you have a bit of time for that. But I did post that first day info assignment. And if you've already done it, great. I graded most of them, or at least, read through them, and it was nice. But if you didn't do that, thank you, Veronica, it is due tomorrow. That's the about you. Yeah, exactly. So there's no math stuff due yet. That is all due September 4th, but I recommend that you try to keep up. So try to do the homework from the sections we went over last week and then up to 5.3, right? Oh yeah, thank you, Joseph. The GroupMe link, again, for those of you that want to join the GroupMe, please do that. I'm not in it, but you guys are all in it and you can help each other and work together and all this good stuff.
Thank you, Professor. Have a good one.
Yeah, thank you. And thanks for the cats that I saw on the screen during class. That was fun. My dog barked the whole way, but now he was taken out. So that's good. Yeah, thank you. Oh, I should.
All right. Have a good night. Thanks.
Yeah, see you guys. Thank you.